So imagine you're looking at a map of the entire universe, right? And you realize that pretty much all of it is blank. That was the situation for astronomers. They could feel the gravity of something enormous and totally invisible pulling on everything they could see. The question wasn't just what is out there. It was, okay, just how much of it is there? That's the mystery we're cracking today.
Just accepting that dark matter was real was a huge step, but that one discovery immediately cracked open two even bigger questions, and it started a scientific journey that would push everything to the absolute limit.
And this is the question at the very heart of our story. Before scientists could even begin to hunt for what dark matter is, they had to figure out its scale. I mean, was this just a tiny cosmic rounding error? Or was the universe basically dominated by something we can't see?
Right. Think of it like a cosmic to-do list. First item on the list, prove dark matter exists. Done. Check. We solved that by seeing galaxies spinning way too fast. So the next mission was crystal clear. Figure out exactly how much of this stuff there is. And to do that, they were going to need a very, very clever tool.
The tool they ended up using is actually based on a really fascinating trick of our own perception, something our brains are doing every single second without us ever noticing.
Here's the key idea. We don't actually see the path light takes to get to our eyes. Our brain only registers where the light is coming from in that final split second. It then just assumes the light traveled in a perfectly straight line, and it builds the picture we see based on that assumption.
A simple magnifying glass shows you exactly how this works. Light travels from an object, the glass lens bends its path, but our brain, still assuming that straight line, traces that bent light back to a new kind of fictional starting point. And that's why the image looks bigger. The more the light bends, the more magnified that image appears.
Okay, now, imagine that lens wasn't made of glass. Imagine it was the size of an entire galaxy. What force in the universe could possibly be powerful enough to do that? Well, the answer is gravity itself, and we have the genius of Albert Einstein to thank for figuring it out.
This incredible effect is called gravitational lensing. Einstein predicted that gravity, the same force that keeps us from floating off into space, could actually bend the path of light just like a piece of curved glass.
So, how on earth does gravity bend light? Well, according to Einstein, mass doesn't really pull things. It literally warps the fabric of space-time around it. Think of a bowling ball on a trampoline. That curve that it creates is gravity. And anything traveling through that space, and that includes light, has no choice but to follow the curve.
And this right here is the crucial point. It's the whole key. The more the light bends, the deeper the curve in space-time has to be. And the deeper the curve, the more mass there must be creating it. It's a direct relationship. More bend means more mass. Simple as that.
Now, this was a revolutionary idea, but for decades it was just that, a theory on paper. Scientists needed some kind of hard, observable proof that gravity could really act as a giant cosmic lens. And when they finally found it, wow, it was spectacular. To see this effect in its most perfect, beautiful form, you need this incredibly rare cosmic alignment. A distant light source, like a galaxy, has to be sitting directly behind a massive object, like another galaxy, all perfectly lined up from where we're looking here on Earth.
Just pause on this timeline for a moment, because it's incredible. Back in 1918, with just a pen and paper, Einstein predicted this should exist. It then took 80 years, an entire human lifetime, for our technology to finally catch up to his brain, when the Hubble Space Telescope captured the proof in 1998.
Discovering this Einstein ring was the smoking gun. It moved gravitational lensing out of the world of theoretical physics and turned it into a proven, practical tool that astronomers could actually go out and use to measure the universe.
So, with this powerful new tool finally confirmed, scientists immediately turned it toward the biggest mystery out there, dark matter. They realized they could now use gravity itself to weigh the invisible.
But hold on, this raised a critical question. Black holes are also massive and invisible. So how could scientists be so sure the lensing they were seeing was from dark matter and not just, a whole bunch of black holes floating around?
Well, the answer is all in how these things interact with light. A black hole does more than just bend light. Its gravity is so intense it actively sucks light in, creating a shadow where nothing can escape. Dark matter, on the other hand, does nothing like that. It doesn't emit light, it doesn't absorb light, it doesn't block light. It does nothing to it. The only interaction dark matter has with, anything is gravity. It's just this colossal, invisible mass that sits there, bending space-time around it. And that unique one-track mind behavior is exactly what lets us isolate it and measure it. So the calculation itself, while it took supercomputers, was beautifully simple in its logic. First, you measure how much the light from a faraway galaxy is being bent as it passes a closer one. Then, you calculate the total amount of mass you would need to create that exact bend. After that, you carefully add up the mass of everything you can see, all the stars, the gas, the dust, and you subtract it from the total. That enormous amount left over, yep, that's your dark matter.
And the result was absolutely mind-blowing. When they ran the numbers, they found that the visible matter, everything we've ever seen or detected, the stars, the planets, us, it only accounts for about 15% of a typical galaxy's mass. A whopping 85% is this invisible, mysterious dark matter.
This discovery solved that original problem of the spinning galaxies. The immense gravitational pull from this giant halo of dark matter is the cosmic glue holding everything together, keeping those galaxies from flying apart. It was the missing piece of the puzzle all along.
And just like that, one of the biggest questions in cosmology was finally answered. But, as science often does, answering one huge question just unlocked an even more profound mystery.
And that's really the key takeaway here. Using Einstein's theory of relativity as a kind of cosmic scale, scientists had finally managed to weigh the invisible. They had a number. They finally understood the true, staggering scale of the mystery they were up against.
So, knowing how much has now kicked off an even more exciting hunt for the next answer on that to-do list. We know it's there, we know how much of it there is, but what particle, what substance, what strange form of matter is it, actually? The search is on.